Hello everyone, we are discussing angular momentum. There are two versions of angular momentum. Basic one is this. Let's say this is the axis of rotation and an object is moving in this direction with velocity v. This is m, which is the point mass. And the point mass is at a distance of r. This is r. This is v. Then angular momentum L is given by R cross P. How do we arrive at this? We have seen this part in the previous lecture. This R cross P is M times R cross V. P is mv, you can take m out. This L, now the magnitude part, is R into P into sine of theta, which you can also write as P times R sine theta. This R cross P, the same as this. When you go for magnitude, R into P into sine of theta. Now when you are presenting everything in terms of magnitude, you can shift R and P. Not in this case. R should be first and then comes what? P. It's a cross product. So this is the magnitude version, and therefore once I group R with sine theta, I get this. This is the direction of linear momentum. Mass m moving in this direction with v. So what is the direction of linear momentum? In the direction of velocity itself. And this angle is theta. The very first laws of rotational motion when we discussed torque. So I have explained how do we decide theta. This is R, this is P or linear momentum. So finding angle between two vectors requires what? Joining them with their tails. So this is theta, and therefore this part, if you drop a perpendicular, this is R sine theta. This is R vector, this is linear momentum vector m into v. Let me show this. In the direction of v, you have P. Because what is P? M into v. Remember like this. That means, just like torque, We can say that angular momentum is linear momentum multiplied by perpendicular distance of linear momentum from the axis of rotation. This is your axis, this is the linear momentum, perpendicular distance. When we developed the case of torque, torque was R cross F. And when we opened the magnitude, I hope you remember this much. This was F into R into sine theta. And I hope you will understand that torque was what? Force multiplied by perpendicular distance of line of force from the axis of rotation. हम एक बार कर चुके हैं, not a new thing. If you are confused, you can see the first lecture. So this angular momentum part for us is now what? Linear momentum multiplied by perpendicular distance of linear momentum from the axis of rotation. Note down this and then we'll write the statement version also. Write down the statement. Angular momentum of a point mass moving with linear momentum P. Angular momentum of a point mass moving with linear momentum P is linear momentum multiplied by perpendicular distance of linear momentum from the axis of rotation. Perpendicular distance of linear momentum from the axis of rotation. Axis of rotation and the linear momentum go for the perpendicular distance. This is the angular momentum of any point mass which is moving with certain linear momentum P. When we go for circular motion of a point mass, that is the special case of this thing. In this figure, there is no circular motion. The particle is moving straight. But if you have a circular motion type of thing, at a distance of r, you have an object which is rotating with angular velocity omega, this point mass. Then for this, in the last class we developed same L upon simplification becomes what? I omega. So this was the case, this is the case strictly for what? Circular motion. This one is for any type of situation. यहां तक अपन लोग लास्ट क्लास में हैंडल कर चुके हैं चीजों को. L equals to I omega is for circular motion. This is for any type. Any type of motion you can use this. Note down this much. Now, who will give me the direction of angular momentum in this figure? What is the direction of angular momentum in this figure? If you can, then write down your answer in the comment box. We can see that angular momentum is a vector thing. What is the direction of this vector? Good. Just look at the rotation, sense of rotation. Somebody standing over here at the position of the axis will find that this object is rotating like this. Although it is moving in a straight line, but as I've told you, कि आप यहाँ खड़े हो जाओ and then start looking at the object, you have to turn your head in this manner. So as this object moves, I have to rotate my head. The sense of rotation gives you what? Direction of angular momentum. In this case, direction of angular momentum is what? Anti-clockwise. Anti-clockwise. Or how do you decide direction of cross product? Join R and P with their tails. So we have R and we have P, but remember you need to join these things with their tails. So this is R and this is P. R, P. And then R cross P means take your right hand, curl your right hand fingers from R to P. This is the curling. R to P. What type of curling you see? Anti-clockwise. Now when you hold your right hand like this, for anti-clockwise rotation, thumb is coming out. So this thumb is coming out. Either you say anti-clockwise or you say along the axis and out. Had it been a clockwise rotation, You will say along the axis but inwards. In this case, this is dot. This means out. So direction of angular momentum is what? Anti-clockwise or dot or out along the axis. For circular motion, यहाँ पर चीजें बड़ी आसान है. यहाँ आपको दिख ही रहा है कि किस तरह का सेंस है. एंटी क्लॉक खत्म. ये out. If someone gives you a figure like this, that we have an object and the object is rotating clockwise and they need direction of angular momentum. Take your right hand, curl, look at the thumb. Thumb is pointing in. Thumb is pointing in. How do you represent inward vector? With the help of cross. This cross gives you direction of angular momentum if object is rotating clockwise. This is clockwise rotation. This is your anti-clockwise rotation. Put on this directional sense and this also. In this case, direction is dot. That's the direction of angular momentum. Let's see how many of you can answer this next part. In this figure, object is initially over here and is moving in this direction with V. We are not changing V, V is kept same. Draw a separate figure. So object is at this position, it's moving in this direction with velocity V. And then after some time, we found that object is over here. This is the new position. Started from this, after some time, it is found over here. When it is at this new position, this distance becomes 2r. Look, I'm not using vector. What I'm saying is, whatever the initial distance is, the r, it becomes 2r. This was r. Object is moving in this direction. And after some time, this distance becomes 2r. You cannot use direct vector sign because when I say r vector, I have the direction part. So I'm giving you the magnitude that whatever this length is, double of that is this. So this is your initial location. This is your final location. So the question is, if angular momentum right here is L, then how much is the angular momentum at the final position? If angular momentum initially is L, then what is angular momentum finally? Let's see how many of you answer this. We're not changing speed. Object is continuously moving with same speed, in fact same velocity. You're not changing the direction also. You can see object is moving this way. Good. कई लोगों ने पहचान लिया that your L final is also L. There is no change in angular momentum. It seems that distance is doubling from r to 2r. But the way I asked you to remember angular momentum is what? Linear momentum multiplied by perpendicular distance. So it doesn't matter if you are at this position, at this position, at this position, at this position, your perpendicular distance from the axis of rotation, perpendicular distance of linear momentum is throughout what? Same. And therefore, your angular momentum, even the direction is not going to change, is what? Same. देखने में ऐसा लग सकता है कि भाई सर ने एंगुलर मोमेंटम क्या नोट करवाया था? r क्रॉस p, और हमारा r क्या हो गया है? डबल. तो कुछ लोग इस तरह का आंसर दे सकते हैं कि डबल हो गया, लेकिन नहीं. इस लीनियर मोमेंटम का, and remember again and again I told you that v is same, so you're not changing linear momentum and you're also not changing the perpendicular distance, and therefore L is same. Those of you who could not answer this part, if they understand it, then write down yes in the comment box. It's a very easy, short answer to that question. Write down the statement for this. As perpendicular distance of linear momentum is not changing, as perpendicular distance of linear momentum is not changing, angular momentum will remain same. Angular momentum will remain same. There is one more way for answering this same type of thing. Well, I told you in the previous class that torque is dl by dt. Now tell me this first. As the object is moving in this direction with v, which is same, how much torque is present? Who can answer this? Object is moving along this line with constant v. This distance is r. So how much torque is present on the object? Who will answer this torque part? Good. There is no torque present. Torque is 0. And why is torque 0? Since force is 0. And how do I know that force is 0? क्वेश्चन बोल रहा है v क्या है सेम. अगर आप v चेंज नहीं कर रहे हो इसका मतलब एक्सेलरेशन कितना है 0. अगर एक्सेलरेशन नहीं है तो फिर फोर्स भी क्या होगा 0. And therefore no force is present, and you know that what is torque? R cross F, and therefore torque is also 0. Now, once you say torque is 0, it tells us C O A M. Now, how many of you understand what COAM is? What is the meaning of COAM? Good. This is conservation of angular momentum. In laws of motion, we did this. F was dp by dt. If F is 0, dp by dt is 0, and then we use what? C O L M. Conservation of linear momentum. If external force on a system is 0, its linear momentum remains conserved. If external torque is 0, what do you mean by external? I'll explain that. If external torque is 0, your angular momentum remains what? Conserved. I'll explain everything in detail, but let's connect the whole part with this previous article. From this position to this position, question says there is no change in the velocity. That means there is no force. That means there is no torque. That means there is no change in the angular momentum, and therefore your L final is same. Hopefully समझ में आ गई होगी इतनी बात. Now, note down like this, and do note down this part also as a side note so that you can relate with linear momentum and angular momentum. And then write few statements. Write down the statement. If external torque on a system is 0, if external torque on a system is 0, then its angular momentum remains conserved. Then its angular momentum remains conserved. Which in short is called COAM. Which in short is called COAM. So, what is the meaning of external? इसको समझते हैं जरा. मैंने अपनी बॉडी पर एक इस तरह से फोर्स जनरेट किया. So if I apply a force on my body myself, then this is called internal process, internal torque. Now, you can do it yourself. Just sit on a revolving chair and then try to rotate your body. Try to turn the whole revolving chair without taking any support from walls or anything like that. Even if you push your body, there is no way you can rotate it. Why? Everything happening is what? Internal. Now, since everything happening is internal, we say that external torque is zero, your angular momentum will remain conserved. Initially, there was no angular momentum present, and therefore, you cannot simply turn the whole revolving chair. Now, how can you produce rotation then? Imagine I'm sitting on a revolving chair and I push this wall in that direction. If I push the wall in that direction, this wall or the board is going to push me in this direction. This push on my body, try to visualize, this is the body and somebody is pushing, the external thing is pushing the body. This push is an external torque, and now I can easily rotate myself on that rotating table or chair. So there are two things, internal and external, और ये internal external की कहानी जैसे ही laws of motion में चलती थी वैसे ही यहाँ पर rotational में है. कोई बहुत बड़ा difference नहीं है. इंटरनली बॉडी पर टॉर्क हो सकता है, चलेगा, बट अगर एक्सटर्नल नहीं है तो आप क्या कंजर्व कर सकते हो? एंगुलर मोमेंटम. With the help of a few examples, you will easily understand these things. Look here. This is a circular disc. Its mass is m, radius is r. Remember, it's a disc, it's not a ring. And in this disc, there is a groove along the diameter. The whole thing is in the horizontal plane. We have a groove, and in this groove, two tiny balls. I hope you can see these. These are two tiny balls of mass m each. They are placed. And this circular disc is rotated with angular velocity omega. These tiny balls of mass m, they are initially placed close to the axis, rotational axis. Just imagine you have a circular disc in the horizontal plane and you have carved a groove along the diameter, and then you place two small balls which can easily roll along the groove, along the length of the groove. When you rotate this, I hope you can feel this part, that these two balls are going to slide along the length of the groove and will reach the end of the diameter. Question is, this is the initial omega which you gave. After giving the omega, these two things, they start sliding away from the center. These two balls, they start moving away from the center. When they finally reach the ends, what is the angular velocity of the entire system? That's what the question is. In case किसी को समझ में नहीं आया, जिन लोगों को आ गया, start solving the question. जिसको नहीं आया है, अगर आप एक कार में हो and car is taking a circular turn, तो आपकी tendency क्या होती है? जो window है उसकी तरफ you feel a force, which is nothing but centrifugal force, a pseudo force. So that type of force is pushing these things, and because of that push, they ultimately arrive over here. So what is omega final when these balls reach the end of the diameter or reach the end of the groove? The first thing, the moment I say that these balls, they start moving towards these ends, the entire thing happening is an internal thing. What will be the external thing? External thing will be you holding the disc and trying to produce a rotation. That will be called what? External. Somebody in the beginning gave the disc an angular velocity. उस वक्त डेफिनेटली आपने टॉर्क लगाया था, डिस्क रेस्ट पर थी, आप आए, आपने रोटेशन प्रोड्यूस किया. एट दैट मोमेंट यू कैन नॉट यूज COM बिकॉज आपने क्या लगाया? टॉर्क, जिससे कि क्या डेवलप हो गया? ओमेगा. नाउ वंस यू गेव दिस ओमेगा, नाउ यू आर गॉन. व्हाट इज गॉन? एक्सटर्नल टॉर्क. Since external torque is gone, the system is going to conserve its angular momentum. So in this question, when you start solving it, you will write like this: since torque external is 0, L initial will be L final. Now, as long as you have bodies performing circular motion, which they are in this case, you don't have to use that R cross P type of thing. You can simply use I omega. Listen again. You can see that everything is going to perform a circular motion. So if circular motion is present, there is no need for you to write R cross P. Use what? I omega. I initial, omega initial, I final ओमेगा फाइनल। अभी ये क्वेश्चन केवल इस चीज का है कि आपको मोमेंट ऑफ इनर्शिया पता है या नहीं पता। आई डिस्क का मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस it was mr square by 2. Take mass of everything as m जिससे कि पूरी चीजें इजी बनी रहे। I've taken mass of everything m. So this is mr square by 2 into omega. These two beads or balls, they're very tiny and close to the axis, and therefore they have no moment of inertia in the beginning. Finally, disk is there. At the same time, these beads, they arrive over here. Just so that you can see it, I've drawn it like this. They arrive at the very end. What are these things? Small things. That means what? Point mass. Point mass at a distance of what? R. What is the moment of inertia of a point mass? mr square. How many balls are there? 2. Into omega final. Done. That's how you answer this question. Initially, disk is present. Balls are close to the axis, and therefore they have no moment of inertia. Initial angular velocity. Disk is always present, but now beads are also at the ends of the diameter. इसलिए उनका भी क्या डेवलप हो जाएगा? Moment of inertia into omega final. Solve this and you get your answer. If you understand this question, then write down yes in the comment box. Now, the same type of profile in a simple theoretical statement type questions, you can expect something like this. They will ask you that when a ballet dancer, she is making a turn with her arms wide open like this, and then suddenly when she folds her arms, then maybe you have seen that her angular velocity increases. The question will be, this is based on conservation of mechanical energy, conservation of linear momentum, or conservation of angular momentum. So what you can see is, if a person folds his or her arms, if you fold your arms like this, there is no external torque involved. कोई आदमी ऐसा नहीं जिसने आपके हाथ पकड़ के फोल्ड करा दिया हो. The whole time what you did, you were making a turn, you were rotating about this axis, and then suddenly you did what? You folded your arms. Now folding your arms is an entirely internal thing, and therefore angular momentum will remain what? Conserved. But what happened when you folded your arms? जो मास दूर था वो पास में आ गया, और जब मास पास में आएगा तो मोमेंट ऑफ इनर्शिया क्या हो जाएगा? डिक्रीज. सो L is I omega, but this I omega is going to remain what? Constant. Now, folding arms means you are decreasing I, but you have to keep your L constant because there is no torque. The only thing you can do is you have to increase your angular velocity. So this folding arm thing is going to increase omega, and that's the reason when a belly dancer folds her arms, her angular velocity increases. So if they ask you on what phenomenon this thing is based on, you will say that this thing is based on conservation of angular momentum. Write down this other statement. When a ballet dancer folds her arms, her angular velocity increases. Her angular velocity increases because of COAM. Because of COAM. That is conservation of angular momentum. Now, let's try to answer this next question. Let me see how many of you will be able to. If temperature of Earth due to global warming increases, then what is going to happen with duration of day? Duration of day is 24 hours. So if you increase the temperature of Earth due to global warming, then what effect does it have on duration of day? It will remain same, it is going to increase, or it is going to decrease. You need to answer these things. Look, when you change the temperature, when you increase the temperature, what is going to happen to ice caps which are present on north and south poles? This is your Earth. And this is the axis of rotation. Earth is rotating about this axis, which passes from north and south pole. And these are the ice caps. Let's say big blocks of ice you have placed over north and south. As you increase the temperature, this ice is going to melt. And as ice melts, the melt water is going to spread itself all around the surface of Earth. Which means what? You are effectively increasing the distance from the axis of rotation. ज्यादातर मास पहले कहां पर था? एक्सिस ऑफ रोटेशन के पास में. जैसे ही आइस मेल्ट हुई, ये पूरा का पूरा वाटर ओशंस के थ्रू एक्सिस से कहां हो गया? ज्यादा डिस्टेंस पर. So increasing temperature is telling you that moment of inertia is going to increase. The entire thing is an internal thing. There is no external torque is involved. Nobody is going to change the angular velocity by using external torque. So since I is increasing, to conserve L, your omega will decrease. Many of you are answering correctly that omega is going to decrease, but what I am asking you is what happens to time. So L will remain same. To conserve angular momentum, you have to decrease your omega. What is omega? Angular velocity. Angular velocity is what? For one complete round, what is speed? Displacement divided by time. Displacement divided by time. That is speed. So what is angular speed? Angular displacement. Speed is what? Distance upon time. Angular speed is what? Angular displacement upon time. One complete rotation means how much angular displacement? 2 pi. One rotation, 2 pi, 360 divided by t. This t is time. Temperature आपने increase किया, omega decrease हो गया. If you are decreasing omega, t is increasing. So your duration of day is going to increase due to global warming. A one-line statement. You can remember it for any examination, school or competitive examination. If due to global warming temperature increases, and what happens to time period? Remember this trick. As T increases, T increases. Done. This is the T trick. So what is the trick? As temperature increases, time period, time to complete one rotation also increases. And note down the entire working. If you understand the entire process, then write down yes in the comment box. Especially those who wrote that T will decrease. Maybe they wanted to say angular speed is going to decrease. But if you are comfortable with everything, then write down yes in the comment box. Look at this question. We have a rod, and this rod can rotate about one of its end. This end is given speed of u. Mass of the rod is m. Its length is l. This is the rod, and it can rotate like this. So what we have done, we have given this end, the lowest end, a velocity of u. We need to find u so that this rod can complete one full rotation. If I give it some u, you can see that it is not completing circular motion, complete rotation. You need to find minimum u that should be given so that it can complete full rotation. Write down the question. Find out minimum u so that rod can complete full rotation. Well, that's not the correct answer. The answer which you have produced, root 5GL. That answer is when you have a rope. It's not a rope, it's a rod. What is the difference between a rope and a rod? Rope can collapse. For circular motion in vertical plane, I hope you remember the minimum u to complete full rotation was root 5gr. But that's not the answer here. A rope can collapse. So if you do not give it sufficient speed, the rope is going to lose tension. But that is not the case with rod. You can, even if speed is not sufficient, it can stay like this. But there is no way a rope and a ball, it can stay like this. It will simply collapse. The answer is not root 5GL. Now let's answer the question step by step. First, answer this part. Can I use COAM? Can I use COAM? Conservation of angular momentum. Yes or no? Well, that's why I gave you this question. Everybody is saying yes, and the answer is no. Now, who will tell me why we cannot use COAM? We cannot use COAM. Who is going to tell me what is the reason we cannot use COAM? Good. Force of gravity is present throughout. जैसे से रॉड ऊपर जाएगी, थोड़ी देर बाद रॉड ऐसी हो गई. जब ये यहां पर है, इट इज गोइंग अप, लेकिन mg कहां लग रहा है? डाउनवर्ड्स. So you have a torque of mg. which is an external torque. And since torque is present, we cannot conserve angular momentum. That's the reason I gave you this question just after the article of angular momentum, so that I can create this kind of confusion. ऐसा नहीं कि आपको जहां क्वेश्चन दिखा आपने वहां लगा दिया COAM, यहाँ टॉर्क लग रहा है, torque of mg, and therefore you cannot conserve the angular momentum. Write down the statement first. In this case, we cannot, in this case, we cannot use COAM as an external torque due to mg is present on the rod. An external torque due to mg is present on the rod. Now, अभी एक क्वेश्चन आप COAM से नहीं कर सकते हैं, therefore forget about I omega. What is the next thing which you can do? COAM, no, we cannot. What about COLM? Can I use COLM? Conservation of linear momentum, yes or no? Good, answer is no. Why? Because force is present. This force is creating what? Torque. This is creating torque, and therefore we cannot use COAM, but as a force it is also present, and therefore we cannot use COLM. But can we use COME? Third thing, conservation of mechanical energy. And remember, there is no friction anywhere between the axis and the rod, and between the air particles are not present for these cases. So can we use COME? What do you think? Yes or no? Good. We can use COME. The moment I say that no frictional forces are present, no dissipation of energy is going to take place, mechanical energy will remain what? Conserved. ये है अपने पास चीजों को सोचने का तरीका. That's how we handle questions. क्या ये लगा सकते हैं? अपने से खुद पूछना होगा कि भाई क्या हम COAM अप्लाई कर सकते हैं? मालूम पड़ा नहीं. क्यों? क्योंकि टॉर्क प्रेजेंट है, क्योंकि फोर्स प्रेजेंट है, कोई एनर्जी का लॉस नहीं हो रहा है. ठीक है, लगाओ COME. Now how do you apply COME? अब वहां चलते हैं. आई होप इतना नोट कर लिया होगा. देखना भाई, ये रॉड कुछ देर के बाद यहां पहुंचेगी. यहां से यहां पहुंच गया रॉड अपना. This is u, and we need u minimum, and therefore when you reach this point your v will become what? 0. That is the meaning of minimum. Minimum means you are giving it enough speed so that it can reach the highest point. Once it reaches the highest point, subsequent motion is automatic. It reaches the highest point and then it will automatically come down. But if your speed u is not sufficient, then it may stop somewhere here and will come back. Stop somewhere here and will come back. It has to reach the highest point. Now, there is a difference in this case and the case of rope, circular motion in vertical plane. In circular motion vertical plane, there is no way the body can stop here. It cannot. In circular motion vertical plane, tension is that which becomes 0 at the highest point when you're using minimum u. Whereas in the case of a rod, a rigid body, when it reaches the highest point, its v should be 0. Now, the rod is moving with u. We have to use COME. COME means kinetic initial, potential initial, kinetic final, potential final. It is moving with u. Its mass is m. How many of you will give me its kinetic energy? What is the kinetic energy? Initial kinetic energy of the rod. Write down initial kinetic energy of the rod in the comment box. Well, had it been half mu square, then I wouldn't have asked you this question. So those of you who are saying kinetic energy is half mu square, no, it is not. कब होती है चीज हाफ mu square? यहां देखना, अगर आपके पास एक रॉड है, सिंपल लॉजिक है, कोई रटने की जरूरत नहीं. अगर आप थोड़ा बहुत भी बेसिक्स क्लियर रखते हैं अपने, तो चीज समझ में आएगी. इफ एवरी पार्ट इज मूविंग विद यू, every part is moving with you. This is the rod. It is moving with you. Every part is moving with you. What is the kinetic energy? In this case, kinetic energy is half mu square. But in this case, half mu square is not correct. Why? Look here, this point. This is the axis, it's not moving at all. This point is moving with the u. Different points in circular motion, different points move with different speeds, and therefore I cannot use half mu square. Write down everything. Draw this figure. Mention this. Every part is moving with you. Yes, we can use half mu square. But in this question, not each and every part is moving with you, only the last part. This is moving with 0. अलग अलग point, अलग अलग speed से move कर रहे हैं. And therefore, half mu square is not valid. Good. One of you has answered the correct way, not the correct answer. What is kinetic energy? इस झंझट से बचने के लिए कि भाई पता नहीं किसकी स्पीड क्या है, हमने बोला एक काम करो ना यार, रोटेशनल में काइनेटिक एनर्जी का फॉर्मूला क्या है? हाफ आई ओमेगा स्क्वायर. यूज दिस. The only thing left is to find I and omega, and we can answer the question. So what is I? What is moment of inertia of a rod? It's a rod of mass m and length l. Write down in the comment box fast. What is moment of inertia of a rod which is rotating with angular velocity omega about its end? Write down this in the comment box fast. By 3. इन्होंने आंसर नहीं दिया था, याद रखना. ml square by 3. And what is omega? What is omega? यार आदमी को पता है v क्या होता है रे? r omega. What is v? u. This hand is moving with u. What is r? Distance. This distance, which is l, into omega. So you have the value of I, you have the value of omega. Now what is initial potential energy? हर आदमी को पता है ग्रेविटेशनल पोटेंशियल एनर्जी अपने हाथ में है. जहां हमारी मर्जी हो हम उसको क्या बोल देते हैं? जीरो. हमने बोला है इनिशियली जीरो है. K final, the highest point, it is going to stop. If it is going to stop, then kinetic energy can only be zero. If rod comes at rest, then U is K is 0. We have to write U final. What is U? Potential energy. U initial we have taken 0. तो 0 से हम कहाँ पहुंच गए हैं अब यहाँ देखना. It's a very good question. It is giving you all these fundamental parts. इधर ये rod, it is rotating about this, and then it is like this. Just so that you can easily see, this is the red for final top position, and this is your initial position shown in black. If you can see it, if you cannot, no issue. So when I say U initial is 0, where is that position where I have taken potential energy 0? And whose potential energy I am interested in? Center of mass. This is the center of mass. Initial. This is the center of mass final. What is the jump? H. And I hope you can see that the jump is L. ये जो अपनी rod है, from this it moves to this position, from black to red. Where is the center of mass of the rod initially? Right here, L by 2. And then finally center of mass is over here, L by 2. L by 2. So what is the jump H? L by 2 plus L by 2, which is L. So when I say potential energy U is 0, this was taken 0 right here. At the location of center of mass, at the initial location of center of mass. H height. Now what is the potential energy? M G H, which is L. If you If somebody takes potential energy at this point 0 and then he thinks that rod has reached this position and they start taking potential energy as mg2l, then everything is wrong. For center of mass, you have to use the potential energy part. I'll explain that also. Why do we use center of mass for potential energy? I'll explain that. Do I have the time? Maybe in the next class, but let's solve this question fast. Half, what is I? ml square by 3. What is omega? U by L equals to mgl. L cancelled and your U is coming root over 6gl. A very important result. If this end, lowest end of the rod, this is rod. I don't know what is this. This was rod. So the lowest point of the rod, if is given minimum U, then this is minimum U, which will make one complete rotation possible. Choti si cheez fast. We cannot use kinetic energy with center of mass. फास्ट समझना, बड़ा इजी है इसको फील करना. Suppose your fan, ceiling fan, it is rotating with angular velocity omega. What is the velocity of center of mass? 0. Center of mass of the fan is not moving at all. So can I use concept of kinetic energy with center of mass? Can I associate kinetic energy with center of mass? No, I cannot. Blades are rotating, but the center of the blade or center of mass of the blade is not moving. And therefore, for finding kinetic energy, I have to find kinetic energy of each and every part. A better way is what? Find out kinetic energy in terms of I omega square. Why? Every part in rotation is moving with different speeds, but they all maintain same omega. बता चुका हूं मैं kinetic वाले part में. So with kinetic energy we do not use the concept of center of mass. What about potential energy? Potential energy में जो rod है अपनी, this rod, let's see the rod in this form. These are the several parts of the rod. Last 30 seconds. These are the parts of the rod. Now how will you find potential energy of these parts? M1 GH1. Look here, first, you have a body made up of small parts. So if somebody needs potential energy, what will they do? They will go for M1. They will write M1 GH1. Let's call it Y1, vertical height. Next, M2. They will go for M2 GY2. Next one, they will go for M3 GY3. Take the G part out. Can you see this is M1 Y1 plus M2 Y2 plus M3 Y3, which was what? Y coordinate of center of mass. So, for gravitational potential energy, we can use the concept of center of mass. For kinetic energy, we cannot. Write down this last line. For kinetic energy, we cannot use concept of center of mass. For kinetic energy, we cannot use concept of center of mass. In just 2 seconds, फिर से. These are the two bodies, two identical blocks. They are moving in the opposite direction with same speed, same mass. What is the speed of center of mass? 0. But is kinetic energy 0? No. Half mu square, scalar quantity. So, for bodies, kinetic energy if is required, we do not go for concept of center of mass. Continue. But for gravitational potential energy, But for gravitational potential energy, we can use the concept of center of mass. We can use the concept of center of mass provided G everywhere is same. Provided G everywhere is what? Same. Look, मैंने आपसे क्या बोला था, अगर हम G को कॉमन ले लें, कॉमन का मतलब हर जगह वो क्या है? सेम. Imagine a rod of height 10 kilometers. You're holding a vertical rod of height 10 kilometers. You cannot use the concept of center of mass for that also. तब वहां क्या हो रहा होगा? M1 G1 M2 G2. जैसे जैसे आप ऊपर जाएंगे ग्रेविटी क्या हो रही होगी? चेंज. G will also change. In that case, you have to perform full integration. You cannot use the concept of center of mass. When can you use? Remember, only if G is what? Same at every part of the body. If you understand this whole article, then write down yes in the comment box. If you do not understand it, write down no, and then you can leave. Thank you very much.